the inverse of the original function, it's just undoing what the original function does. It gives you the identity, it gives you whatever is in this argument. So this is inverse notation for trig. This is for any function. This is cosecant. It's not to the negative first. That's inverse cosecant of cosecant. So it undoes the cosecant function, gives you 4/3 pi. This one's trickier though, because cosecant of secant doesn't undo the function, right? Cosecant is 1 over sine, secant is 1 over cosine, so those don't quite match up. So what you can do is you can take this off to the side, secant, inverse secant of -2, say that's equal to some y value. We want to know what this is equal to. So you could take secant of both sides of this equation to get -2, because the secant of inverse secant undoes it, and it leaves you with -2 equals secant y. And so that's just a trig problem where you're supposed to find the angle that gives you -2. Or you can think of it like this, -2 equals 1 over cosine y, if you're not used to working with secant. Okay, because if you put it in terms of cosine, then you multiply cosine to both sides, divide -2 from both sides. So what angle? Actually, there's a few here. There's two that are between 0 and 360. But what angle makes the cosine ratio equal -1/2? And if you've seen in my other videos, if you have a right triangle, 30 degrees in a unit circle, right triangle. If one is the hypotenuse, 30 degrees corresponds with 1/2. So what we're looking for is the angle that makes, we're looking for 30 degrees that makes a negative cosine. And if you use those mnemonic devices, one is like all students take calculus. All are positive in the first quadrant, just sine is positive in the second quadrant. So that means cosine can be drawn here if we want a negative cosine, because just sine and its reciprocal cosecant are positive here. That means cosine is negative in the second quadrant. And so we needed a reference angle here. If it's cosecant, we need this to be 60 degrees. That way this is 30 degrees, and it's the unit circle, so we put a 1 here. That way the 30 degrees is the adjacent. We need the adjacent to be -1/2. Now if you do the cosecant ratio here, cosecant of our reference angle, cosecant of 60, is the adjacent divided by the hypotenuse. We found the angle. It takes 120 degrees, starting from the initial side to this terminal side. It's 120 degrees. So now we're just trying to solve this smaller equation. Now that we know what secant, inverse secant of -2 is. Oh, I already forgot. I think it was 120, right? And just do the same thing. Set that equal to y. If you're not used to working with this is sine 120, right? It's the reciprocal of cosecant. So you can just multiply sine 120 to both sides. And then divide, oh wait, no, we don't need to do any of this. Sorry, I was thinking of the last problem. You can just evaluate what sine of 120 is now that we've got it in terms of sine, cosine. Here's 120 degrees, right? So that means you have 60 degrees in here, just like the other triangle we drew. No coincidence there, right? So if we're trying to evaluate sine, this is square root of 3/2, according to our special triangles that we memorize. Right? Across from 60 is always square root of 3/2. So the opposite divided by the hypotenuse is square root of 3/2. So we'll put square root of 3/2 in for sine of 120. So it just means we need the reciprocal, so 2 square roots of 3, or in other words, y equals 2 square roots of 3/3, because you can rationalize, rationalize the denominator, multiply the top and the bottom by square root of 3.